Now, in the previous class, we discussed about what we can say various types of frame structure and then various types of foundation, right? Means there is a pile foundation, combined footing, raft, and so on. Again, it is depend upon the type of building. Again, it is depend upon the type of building and type of load coming over that particular foundation. Second parameter is SBC of soil. If SBC is less, then ultimately we have to find out some other alternative so that load should be transferred to the firm strata of your earth, right? Now in this case, we may go for the pile foundation. Now in case of pile foundation, the calculation is very easy. What we have to do, we have to just calculate the quantity required for the pile. And how we are going to find out? That is pi by 4 d square into what is the depth of that particular pile. But when we are going to consider the trapezoidal footing, in that trapezoidal footing, some calculation we have to be do accordingly. So before starting the trapezoidal footing and other things, first we will consider the plan. In plan, we are going to define the various parameters, and on the basis of that parameters, we are going to do the further calculations, which we are generally do in case of frame structure, right? But clear, in case of frame structure, wall acts as a non-structural member. That's it. Means wall does not play any kind of part in load transfer. It is just for the partition point of view, right? So there is no any kind of load transfer. So therefore, there is no any kind of continuous footing provided below the wall, right? So what we are going to do, suppose there is a column at this end and a column at this end, then over this two column, we are going to provide the floor beam, and over this floor beam, we construct this particular wall, right? Then next one is to support this slab, we again provide one what we call as roof beam over there, and then we support it. So what happened? Suppose this is the slab, then we are going to provide some kind of beam, and below this there is a wall, and this wall is resting on again floor beam, resting on again floor beam, right? And this is running this. Clear? So this is the basic fundamental, and this wall is again running in this. So at the time of calculation of wall height in case of frame structure, that wall height is not bottom of this slab to the top of this slab. Then what it is? It is a distance in between bottom of your beam and this. Whereas in case of load bearing structure, we are going to consider the total. In case of load bearing structure, we are going to consider the total height. Clear? So generally, if you are going to provide the 3-meter height, that is 10 feet, then in that case, this height generally we are getting in between 2.6 to 2.7. 2.6 to 2.7 meter, right? If we are considering this as 3 meter, if we are considering this as 3 meter, is it okay? Now, consider plan. So this is external wall. The thickness of this external wall is 230 mm. Thickness of this external wall is 230 mm. Now, we are providing the internal wall. Thickness of internal wall is 115 mm. thickness of internal wall is 115 mm. So external wall, it is 0.23 meter. Internal wall, it is 0.115 meter. Whereas in case of load bearing structure, we consider the thickness is, I suppose, 0.4, right? The thickness is more in case of load bearing structure, but in this case, the thickness is less. Now, when there is a less thickness, it means that the carpet area of your building is going to be increased. When you are utilizing the less thickness wall, then carpet area is increases. And what exactly the carpet area means? Carpet area means actual usable area of building. Carpet area is actual usable area of building. Right? Now, in this case, we are writing some kind of column. Suppose this is first column. This is another column. So this is C1. This is again C1. This is C2. And this one is C2. Okay. Now my point is C1 is 0.23 by C1 is 0.23 by 0.4 and C2 is 0.23 by 0.3, just for the consideration. Or you can say 0.23 by 0.23. Clear? Now the second parameter is now related to the data given pertaining to this C1. What data we want? First, write down serial number, name of footing, serial number, name of footing. Let's start from this. So serial number, name of footing, name of footing. Third one is excavation size, excavation size. The next one is size of footing, size of footing. Next one is thickness, or instead of thickness we can say depth. Depth. In this depth, two parameters are there, capital D and small d. So I'm writing small d and then capital D. And name of column. Name of column. So serial number 1, say footing F1. The size of excavation is say 1.8 by 1.5. Size of excavation is say 1.5 by 2.1. Then size of footing. Size of footing is 1.2 by 1.8. Then small d and capital D. Small d is 0.2, capital D is 0.5. And over this F1, we are supporting C1 footing. Sorry, C1 column. Now, second one, footing is F2. Footing is F2. The size of excavation is again 1.5 by 1.5. Footing size 1.2 by 1.2. Depth 0.2, and this is 0.35, and column is C2. Column is C2. Clear? So this is the data given to us. And with this data, there is one more parameter is given to us. That parameter is called as cross section of that footing. Cross section of that footing. So just write down this data, so we will redraw that element. Cross section of footing. Is it okay? इसका डायमेंशन क्या रहेगा वो बाद में देखते हैं. Sorry, I can't. I will let you. Just give me a chance to draft that element first. Is it okay? Now. ये हो गया लिख के. Now, draw cross section of footing. This is PCC. उस कॉलम में एक और ऐड कर देना, थिकनेस ऑफ PCC is 0.1. वो जो आपने टेबल बनाया उसमें एक और कॉलम ऐड करो, थिकनेस ऑफ PCC is equals to 0.1 मीटर. And it is same for F1 as well as F2. Thickness of PCC is 0.1 meter. Clear? Now this is the cross section. This is the cross section. Now this is ground level. This is plinth level. Ground level and plinth level. Now this element is basically called as depth of excavation, which is not defined in your drawing. Depth of excavation is not defined in your drawing. What structural engineer write down over there? They clearly mention that depth of excavation should be up to that level at which you are getting that SBC. समझ में आ गया? If you are designing this particular foundation for suppose 25 ton per meter square or say 250 kilonewton per meter square, then what structural designer write down in their drawing over here? This is the depth of excavation, and you have to do the depth of excavation, or you have to do the excavation till you reach this bearing capacity. You reach this bearing capacity. So it is not necessary that you will reach that bearing capacity at say 1.5 meter, 2.1 meter, 4.8 meter, whatever. So why they are writing in this way? To safeguard themselves. Okay, if they clearly define that depth of excavation is say 1.5 meter, then what happened? Whether at 1.5 meter you are getting that SBC or not, it is question mark. So to save ourselves, means structural designer to save themselves, what they write? They write this is the depth of excavation, and the depth of excavation is up to that level at which you are getting that particular SBC. And in structural design, SBC is clearly mentioned at top corner, children. Right top corner. Is it okay? तो यहाँ पे भी क्या लिखते देंगे वो? Depth of excavation till SBC required SBC is to be getting or to be find out. Okay. लेकिन हमारे कैलकुलेशन के लिए हम क्या करते हैं? We consider depth of excavation as 3 meter. Okay. So we are writing this is 3 meter. लिखो यहाँ पे this is depth of excavation. Note करके लिखो depth of excavation is not clearly mentioned in your structural drawing. Depth of excavation is not clearly mentioned in your structural drawing. Clear? So excavate till you will get the firm strata. तो ये जो लोग बोलते हैं ना 3 मीटर एक्सकेवेशन करना है, 2 मीटर एक्सकेवेशन करना है, everything is depend upon the type of strata and type of bearing capacity you are going to consider in actual practice. That's it. अगर आपको 3 मीटर पे नहीं मिल रहा है firm strata, excavate more. Right? साइड पे एक GMR शीट करके मेंशन ये करते हैं, मेजरमेंट रहता है। GMR शीट में वो लोग क्या करते हैं, लोकल लेवल्स मेजर करते हैं। सपोज अगर हमारा ये कॉलेज है और 5000 स्क्वायर फीट का अगर आपको कंस्ट्रक्शन करना है, so what happened, every 5000 square feet you are not getting the same elevation of soil, you have the undulation. So what we will do for the measurement point of view, we measure the what we can say spot level of that soil where we are going to do the excavation, and then we do the excavation. So कितना excavation किया ये हमें पता चलता है. So that GMR sheet is always maintained at particular site condition. Is it okay? Now in this case, this is a trapezoidal footing. This is a trapezoidal footing. Now in this trapezoidal footing there are two parts. The first part is a rectangular part. So this is my first part, and this part is second part. Now this first and second is constitute of trapezoidal footing. So trapezoidal footing has two parts. First one is rectangular part, and second one is trapezoidal or slope part. And then first and second we add up, it will give me the total quantity of trapezoidal footing. Total quantity of trapezoidal footing. So what I will do, I will first draw a plan of this. ये तो क्रॉस सेक्शन हो गया। अब इसका प्लान कैसे रहेगा? This is the footing line. This is excavation line. As in case of BDD, excavation line is always drafted in dotted line. So this is excavation line. This is footing line, and over this two parameters, it is again necessary to locate this is not column, this is not column. Okay, ये points को locate किया हमने, Clear? Above this location, column will start. So if you want to locate the column, then that column is inside it. This is column. This is column. Clear? So dotted line is the excavation line. Then this line is my foundation line. This is the line of top of your footing. Clear? Now, in this case, this distance is called as small d. This distance is called as small d, and this distance is called as capital D. This distance is called as capital D. So what exactly the small d is? Small d is nothing but it is a depth of your rectangular part of trapezoidal footing. Right down. Small d is what? Small d is depth of rectangular part. Depth of your rectangular part. लेकिन ये rectangular part किसका part है? Trapezoidal footing. So small d is depth of rectangular part of trapezoidal footing. Okay. Now what do you mean by capital D? Capital D is total depth of trapezoidal footing. Total depth of trapezoidal footing. Total depth of trapezoidal footing. कभी भी स्मॉल डी मतलब ये डिस्टेंस होता है और कैपिटल डी मतलब यहां से यहां तक का डिस्टेंस होता है. Never consider this distance as capital D. कोई डिजाइनर ये डिस्टेंस कैपिटल D करके डिफाइन नहीं करता. These are the standard notations. Right? अगर अभी जो हमने टेबल लिखा उसमें देखो स्मॉल डी कैपिटल डी चेंज है. अगर स्मॉल डी कैपिटल डी इक्वल रहता है देन दैट फुटिंग इज कॉल्ड एज स्क्वायर और रेक्टेंगुलर फुटिंग. स्मॉल डी और कैपिटल डी मैच हो गए इसका मतलब इतना ही फुटिंग बनेगा. तो अगर वो दोनों मैच हो गए तो उसका मतलब है आइदर दे आर रेक्टेंगुलर फुटिंग और दे आर स्क्वायर फुटिंग बट दे आर नॉट ट्रापेजोइडल फुटिंग. इज इट ओके? नोट करो. एक्चुअल प्रैक्टिस में ये सारी चीजें होती है ड्राइंग में. If small d is equals to capital D, then in that case that footing is not called as trapezoidal footing. That footing is called as either square or rectangular depending upon the size of footing. Depending upon the size of footing. Clear? Now, suppose this column is say C1. This column is say C1. So can you tell me the size? क्या था column का size? 0.23 by 0.4. अभी मैं consider करता हूँ कि ये longer dimension है. Suppose this is 0.4. Suppose this is 0.4. अब longer dimension को तो longer dimension आएगा excavation का. So therefore this size is 2.1 size of excavation and this size is how much? 1.5 or 1.8? 1.5 size of excavation then. Clear? Next, footing size. This is 1.8 and this one is 1.2. अब रहा पॉइंट ये, क्लियर? अब ये कैसे डिसाइड करते हैं? वो जो ऊपर में जो ऑफसेट दिया है, हाउ दैट ऑफसेट इज गोइंग टू बी डिफाइंड, दैट इज द पॉइंट. ओके, नाउ प्रैक्टिकली व्हाट हैपेंड, अब ये कॉलम कास्ट करने के लिए आप शटरिंग लगाओगे. डू यू नो द शटरिंग जो प्लाई का रहता है? अब वो शटरिंग लगाने के लिए मिनिमम वी वांट 50 mm स्पेस. फॉर व्हाट? अब इस कॉलम को कास्ट करने के लिए मुझे यहाँ पे प्लाई लगाना पड़ेगा और ये प्लाई यहाँ पे रेस्ट होगा. तो इसके लिए मुझे मिनिमम 50 mm का गैप चाहिए या स्पेस चाहिए टू रेस्ट दिस प्लाई ऑफ शटरिंग ऑफ कॉलम ओवर दिस फाउंडेशन. तो इसका क्या मतलब है? ये मिनिमम डिस्टेंस मुझे कितना चाहिए? 50 mm on this side and 50 mm on this side. अब 50-50 मतलब 100 mm. तो ये जो टॉप फेस है इसका डायमेंशन कितना हो जाएगा? Whatever the dimension of this column plus 0.1 plus 0.1. So therefore the dimension of column is 0.4. It means this dimension become 0.5. Clear? 50 mm on this side, 50 mm on this side becomes 100 mm. 100 mm means 0.4 plus 100. And what is the other dimension of this column? 0.23. दूसरा डायमेंशन क्या है? C1 का 0.23. So 0.23 means again 50 on this side, 50 on this side become 100. So 0.23 plus 0.1 becomes 0.33. So this dimension become 0.33. Clear? So यहाँ पे note लिखो, but it is not always necessary that you are going to consider 50 mm only. Some people they may consider 75 mm also. 75 mm also. Second, it is again depends upon type of what we can say shuttering material you are going to use. Whether you are going to use that plywood, whether you are going to use the plank, whether you are going to use the steel plates. Depending upon this distance may change. So it is not necessarily always 50 mm. Minimum we require 50 mm. If you want, you can take at 75 mm. Some people they consider 100 mm also. So यहाँ पे लिख लो. This is 50 mm minimum. 50 mm minimum. ठीक है, इतना क्लियर है. अब उसके अंदर अगर आपको कॉलम का साइज डिफाइन करना है तो भी डिफाइन कर सकते हो. दिस इज 0.23 एंड दिस डिस्टेंस इज 0.4. इफ यू वांट यू कैन राइट स्केच थोड़ा एनलार्ज कर. क्लियर? ये सबसे बेसिक इंपॉर्टेंट पॉइंट है टू अंडरस्टैंड. क्लियर? ऐसा ही पैरामीटर C2 का रहेगा, बट दिस इज कॉल्ड एज टिपिकल सेक्शन. टिपिकल सेक्शन मींस that section is applicable to some other column also. So it is not necessary कि अगर आपने 4 कॉलम दिए तो चारों के सेक्शन दो. You just give the detail of one section and write down it is a typical section of say C1 or typical section of C2. That's it. It is not necessary अगर 10 कॉलम है तो 10 कॉलम के ड्राइंग बनाते बैठो. It is not necessary. Clear? So therefore this is a typical section. So typical section means whatever the data we are going to consider over here, that data is replicated for C2 depending upon its dimension. Clear? चलो अब इसका कैलकुलेशन करते हैं. So draw that lines. Serial number, particular. We have the constraint of space. Okay. So serial number, particular, number, LBH. So serial number, particular, number, L, B, H, quantity. Here, the first element is excavation. So first element is excavation. And again, we are doing the excavation at an interval of what? 1.5 meter. So we are going to consider 0 to 1.5 meter. 0 to 1.5 meter. Now we are doing the excavation for what? We are doing the excavation for footing 1. We are doing the excavation for footing number 2. So I am just writing this is footing number 1, F1, footing number 2, F2. Now we are going to provide footing number 1 for what? C1. So measure the number of C1. Total 9. So I am writing 9 and F2 for C2. Now for F1, what are the plant dimension? Plant dimension means this dimension, this and this. So plant dimensions are right. So 2.1 by. So this is 2.1 by 1.5. Second F2. 1.5 by. Right? Now, H means what? Depth of excavation. H means depth of excavation. So, now what I am going to do in this case, I am going to do in this case 0 to 1.5 meter. If I consider this as 0, then I will consider up to 1.5 meter. And then from this patch to this patch, again it is 1.2. Sorry, 1.5. So depth of excavation is 1.5, 1.5. Fully multiplication and calculated quantity. Tell me final total. How much? 42.1. Unit is cubic meter. Say 49. Okay. Now next one. Second. Now what we want? We want excavation for 1.5 meter to 3 meter. So excavation 1.5 to 3 meter. Again, we are going to do the excavation for F1 and F2. Now again, numbers remain same. So 9. Plant dimension remains same. Now depth of excavation is from 1.5 meter. We are reaching up to 3 meter. Means what is the interval? 1.5 meter. So therefore this is 1.5, 1.5. So quantity is same, 49 cubic meter. But remember, amount required to execute this quantity is lesser than amount required to execute this quantity. So therefore we are calculating separately. अगर यहाँ पे डेप्थ ऑफ एक्सकवेशन में 2.7 करना हो then this is 1.5 से लेके 2.7. So 2.7 minus 1.5 1.2. तो यहाँ डेप्थ ऑफ एक्सकवेशन 1.2. Are you getting the point? Yes, sir. This is 0, 1.5. This is 3. So this is 1.5 meter. This is again 1.5 meter. Suppose 0, 1.5, 2.7. Then this is clear? नहीं दिया तो 3 मीटर ले even though से सबका एक स्टेज में सीखा we are simply consider 3 meter, 3 meter, that's it. No bifurcation. ठीक है? See again, it is not necessary for me to consider each and individual element. Okay, हम ले रहे हैं because we have some kind of time. Otherwise, अगर मैं इस बिल्डिंग का अगर एस्टिमेट एग्जाम पॉइंट ऑफ व्यू लूं, so within 2 lectures we can finish. Within 2 lectures, there is no necessity to do whatever the data we are going to consider, whatever the detail we are going to consider. But remember, whatever you are going to understand through that exam point of view, it is not applicable at site. Site requirement is something different. So we just try to consider both aspects, your exam aspect as well as the site aspect, so that if you want to work in civil, then you can know something about the estimation. Otherwise, from the bookish point of view, it is something else. Clear? I just write down the formula, write down the details, and that's it. यहाँ पे bifurcate करने की जरूरत नहीं है. Just I write down 3 meter depth of excavation है 3 लो. But at site this is not. Clear? So therefore we require some time, and this is the basic thing of estimating, and the basic thing what you require at your construction site. Clear? So now next, इसके बाद कौन सा एलिमेंट आएगा? PCC. So write down third. Third element is PCC. Now remember, जितना हम एक्सकेवेट करेंगे उतना PCC करेंगे. So plan dimension of excavation is equals to plan dimension of PCC, right? Plan dimension of PCC. Plan dimension means what? Plan dimensions means when you are going to visualize that element from the top, then whatever the dimension you are going to visualize, that dimension is basically called as plan dimension. Clear? So plan dimension of excavation is same for PCC. Plan dimension of excavation is same for PCC. Plan dimension of excavation is same for PCC. Clear? अब plan dimension कौन से आपके excavation के ये dotted line के dimensions. क्या है इसके dimension? 2.1 and 1.5. So write down those dimensions. So 2.1, 1.5, 1.5, 1.5. But what is the thickness of your PCC? 0.1 meter. This is called as thickness of PCC, which is equals to 0.1 meter. 0.1 meter. So therefore, I am writing 0.1, 0.1. Number of footing उतने रहेंगे, F1, F2, number भी same. ओके, थर्ड पॉइंट की अब साइड पे क्या होता है? at your construction site generally, ये जो मैंने यहाँ पे ऑफसेट डिफाइन करके दिया है 0.15 on this side, 0.15 on this side, अगर आप देखोगे तो ये 0.15 मिलेगा आपको, and this offset is again 0.15. साइड पे लोग क्या करते हैं कॉन्ट्रैक्टर, instead of considering 0.15 meter, what they do, they consider 0.4 on this side, 0.4 on this side. And what they give the justification? They give the justification that ये जो पीसीसी करोगे तो यहाँ पे आप प्लाई लगाते हो, शटरिंग बॉक्स, उस बॉक्स को सपोर्ट करने के लिए we want some kind of space और some kind of space create करने के लिए depth of excavation को 0.4 लेते हैं instead of 0.15. Now it is in your purview as a PMC, as a client, whether you are going to consider the quantity of excavation as per point or as per site condition. As per point or as per site condition. कि site से हिसाब से लेना है या नहीं. दूसरा point, अगर suppose you give the permission for the contractors or the excavation that you can do 0.4 on this side, 0.4 on this side. Though it is mentioned 0.15. लेकिन पीसीसी करते समय don't do the PCC of whatever you are excavating, considering 0.4, 0.4. Then do the PCC according to the size mentioned in your structural drawing. तो ये दो condition साइड पे होगी. Clear? And the rate of excavation is around 200 to 290 rupees per cubic meter. Clear? If you are going to do the excavation in suppose soft rock, then the rate may be 320. If you are going to do the excavation in somewhat hard rock, then the rate of excavation is around 350 to 400. Clear? ये पैरामीटर साइट पे होता है. Clear? तो उसमें दो कंस्ट्रेंट है. If you are giving the permission that size of excavation increase कर लो, तो strictly warm करो कि PCC को एक उतना मत करो जितना आपने एक्सकवेट किया. In that case, restrict your PCC to the size. Clear? चलो next. अब थर्ड पैरामीटर इसमें हमें कैलकुलेशन लगेगा, that is the calculation of footing RCC. Fourth one is calculation of footing RCC. ठीक है. अब इसके लिए एक फॉर्मूला है, कैलकुलेशन ऑफ RCC of F1, calculation of RCC of F1. Then it has two elements. First one is rectangular part and second one is trapezoidal part. So what we first we calculate the rectangular part. Rectangular part. Okay. Now when we are going to calculate for the rectangular part, how you are going to calculate the volume? You know the size of footing. Size of footing मतलब ये एलिमेंट आपको पता है. Rectangular part की डेप्थ आपको पता है. So planned dimension of your footing multiplied by what? Depth. You will get the volume. You will get the volume. So therefore, what I will do? Say this is V1. Say this is V1. ये जो rectangular part है, इसके planned dimension आपके पास है. Size of footing is given to you. So tell me size of footing. 1.8 by 1.2. This is the size. ये size और वो dimension में जो है parameter आएगा, that parameter. Now what is the depth of your rectangular part? This. और ये rectangular depth आप किससे define कर रहे हो? Small d. Value of small d given to you or F1. So therefore this is small d. Right? So simple multiplication. sorry, 0.43 ठीक है क्यूबिक मीटर क्लियर। अब ये तो हो गया रेक्टेंगुलर पार्ट, ये आपने कैलकुलेट कर लिया। बट व्हाट अबाउट दिस ट्रापेजोइडल पार्ट? ये ट्रापेजोइडल पार्ट मतलब वो नहीं है BD प्लस SG स्क्वायर जो आप FM में चैनल कंसीडर करते हो, या फिर जो एस्केलेशन में हमने रोड के लिए कंसीडर किया था BD प्लस SG स्क्वायर, ये नहीं है। इट इज अ सॉलिड पोर्शन, clear? It is slant on this side as well as this side, clear? Now we want to calculate that volume. So how we are going to calculate? Again we are going to utilize the formula. So second part is trapezoidal part. Trapezoidal part. Now in this case, we are going to utilize, or we are going to say V2 is equals to H by 3 under root of A1 plus A2 plus A1 into A2. Clear? What? V2 is equals to H by 3 under root of A1 plus A2 plus A1 into A2. Now what exactly the A1 and what exactly the A2? So A1 is area of, you can say area means plan area of trapezoidal at the base. Base मतलब ये trapezoidal है, उसका base ये हो गया, तो यहाँ का plan area चाहिए मुझे. So this dimension is not matching with this dimension. जो footing का dimension रहेगा वही dimension रहेगा. So therefore I am writing which is equals to 1.8 into 1.2. So I am going to calculate A1 at this base level. So this is A1. Area at this location. Here. And what is A2? A2 is area I want at this location. So this is A2. अब इसमें A2 कौन सा हो जाएगा? ये portion, right? So this is A2 and this one is A1. तो अब ये A2 कितना है आपका? 0.5 by 0.33. So therefore A2 is 0.5 by 0.33. So tell me this one. 2.16 and this is 0.165. Clear? Now the next is what is H? So H is nothing but it is a depth of trapezoidal portion of trapezoidal footing. हमने small d क्या लिखा था? It is a depth of rectangular part of trapezoidal footing. So small h is it is a depth of trapezoidal portion of or trapezoidal part of किसका? Trapezoidal footing. Clear? So therefore this is small h. लिखो वहां पे. It is a depth of trapezoidal part of trapezoidal footing. It is a depth of trapezoidal part of trapezoidal footing. Clear? So therefore H is equals to capital T minus small d, which is equals to 0.5. So put up this value in this equation. So V2 is equals to 0.3 by 3 into under root of 2.16 plus 0.165 plus 2.16 into 0.165. This is so V2 is 0.163. कैलकुलेशन चेक करना है, ठीक है? समझ में आया? Now अब लिखो volume of F1 is equals to V1 plus V2. V1 plus V2. V1 plus V2. Now what is V1? 0.43. What is V2? ठीक है, दोनों का एडिशन ठीक है 0.59. अभी कैलकुलेट करो फॉर F2. उसको लिख लो क्या था फॉर F1 V1 plus V2 टोटल बना दो ठीक है. Now second for F2. Now in case of F2 what is the rectangular size? F2 का क्या देखोगे आप? footing size कितना दिया? 1.2 by 1.2. Now what is the depth of your rectangular part? In F2 में rectangular part का depth कितना है? 0.2. So this is 0.2. तो ये वैल्यू चेंज हो जाएगा. Zero point 288. Now, trapezoidal part. Formula से A1 क्या रहेगा? A1 means यहाँ पर इसका एरिया क्या आएगा? Which is same जो आपका साइज है footing का F2 का. So this is 1.2 by 1.2. अब दूसरा, what is the size of column C2? 230 by 230. फुटिंग 2 पे कौन सा कॉलम है? C2. C2 का साइज क्या है? 0.23. 50 mm इस साइड में 50 mm इस साइड में टोटल कितना ऐड करेंगे? 0.1 मीटर. तो 0.23 becomes 0.33. मतलब ये साइज कितना हो जाएगा उसके लिए? 0.33. अदर डायमेंशन भी सेम है कॉलम का 0.23. तो उसमें भी अगर 0.23 है और 0.1 ऐड किया तो 0.33 by 0.33. So therefore this is अब अगर कंफ्यूजन हो रहा है तो दिस इज 0.23. दिस इज 0.23. So this becomes 0.33. 0.33. क्यों? ये 50 सेकंड 0.05 0.05. ठीक है क्या आ रहा है? 1.44 0.09. ठीक है. These कितना कैपिटल 0.35 minus 0.2. So this becomes 0.15. ठीक है. वहां पे वैल्यूज चेंज करते हैं. This is 1.44. This is 0.009. Which one? 0.108. So this is again 1.44 into 0.108. So what is it? Zero six five. Check it. And this add to V1 plus V2. Point 0.88 plus this 0.3 cubic meter, right? अब ये तो हमने एक फुटिंग के लिए लिखा एक F1 एक F2, लेकिन है तो अभी उस टेबल में जाओ, लिखो वहां पे आरसीसी ऑफ फुटिंग, आरसीसी ऑफ फुटिंग, ये तो कैलकुलेशन किया हमने, अभी लिखोगे आरसीसी ऑफ फुटिंग, नीचे लिखो F1 नंबर में F1 कितने 9, और वहां पे जैसे आपने F1 लिखा 9, इसके बाद में लिखो एट द रेट ऑफ कितना कंजम्पशन है एक फुटिंग का, और F1 0.592, so this is 0.592 cubic meter, तो क्वांटिटी में कितना आएगा this into this, clear? तो क्वांटिटी आप टेबल वाइज लिखो, ठीक है? तो छोड़ो कि इसको एल भी लिखना, बी भी लिखना, एक्स भी लिखना, ऐसे लिखो, आपको समझना चाहिए कि क्या किया आपने। 9 फुटिंग है, एक फुटिंग के लिए कितना कंजम्पशन है, तो क्वांटिटी कितना है F2 कितना 2 एट द रेट कितना कंजम्पशन है एक फुटिंग का, क्लियर? एंड देन समेशन, ठीक है? So this is 6.08 cubic meter. एक आपका जो गाड़ी आता है ना रेडीमिक्स का 6 to 7 cubic meter उसमें मटेरियल आता है कंक्रीट, उस गाड़ी को बोलते हैं टीएम, ट्रांजिट मिक्सर, ठीक है? कितना स्लम्प रहना चाहिए इफ यू आर वर्किंग विद फाउंडेशन और फुटिंग, स्लम्प का वैल्यू कंक्रीट का कितना रहना चाहिए? कितना? What is the value of slump in this concrete? डिफाइन होना चाहिए। If suppose if you are getting this slump of say 30 mm or 20 mm and you want to do the concreting of the foundation, then whether it is possible to do. Secondly, how you are creating this shape of trapezoidal right side, because you are just introducing the setting at this point only. You are not placing any kind of setting over here, so that mason has to define that particular shape. So how that shape is going to be defined? This is again point. Calculation easy hai. H/3 A1 A2 A1 into A2 whatever. But the thing practically, how this footing is going to be cast at site. Because we are not placing any kind of shuttering material over here, we are not placing any kind of shuttering over here. What we will do, we will place the shuttering at this point and this point. The second point is how we are going to do the compaction of this concrete. This is the second point, how we are going to do the compaction. Clear? So, ये points essential. See, calculation is very simple. If you know the drawing, you can do it. But how practically they are going to do? अगर chance मिलता है तो एक बार देखो. Secondly, do you know the needle vibrator? Then what is the minimum diameter that you are going to utilize in this concrete for the compaction purpose? Whether you are going to use the 30 mm, whether you are going to use the 25, or whether you are going to use the 40 mm. It is again point. Clear? Secondly, how the reinforcement cage is going to be considered or going to be laid down over here. कि reinforcement का cage कैसे रहेगा? So, in case of particular screen, in this particular part, there is no any reinforcement. We are providing the reinforcement at this part only in the form of mesh. In the form of mesh. Okay? बाकी कुछ provide नहीं कर सकते हैं. ठीक है? तो यहाँ there is only concrete. So what should be the value of slump? ठीक है? ये check करो. It is necessary to define. Here, suppose slump अगर बहुत ज़्यादा है, so what happens? You cannot keep the shape of this structure. अगर slump कम है, then there is a chances of what? Segregation. There is a chances of uncompaction. There is a chances of, because of uncompaction, there is a chances of voids. And because of voids, the strength of this footing is going to be decreases. एक जनरल थंब रूल जो रहता है 1% अगर voids रहे तो 5 या 6% स्ट्रेंथ कम होता है. Right? Thumb rule. But according to that thumb rule, whether we are going to consider that slump value, इस पे लोग ध्यान नहीं देते. They do the calculation. They said M25 का concrete मुझे चाहिए. But what should be the slump value? Second, there are two slump value. वो बंदा क्या करता है साइड पे, मतलब जब आपके TM में, मतलब ट्रांजिट मिक्सर में जब कंक्रीट ऐड ऑन करता है, साइड पे एक स्लम्प लेता है, स्लम्प का फोटो आपको भेजता है, बोलता है ये 100 mm का स्लम्प मुझे मिला. लेकिन आपके साइड से जो प्लांट 400 कंक्रीट आ रहा है, it is around say half an hour. So within that half an hour, whether that slump is retained or it is decreases. So what we want this slump at side instead of at that place. तो कुछ लोग वहां के फोटो को दिखा देते हैं कि ये स्लम्प मुझे मिला, एक्चुअली वो नहीं रहता. Clear? So these are the points. Anyways, concrete and other thing. So next quantity is, I want to calculate now the quantity of RCC of column up to plinth level. What I want? I want RCC of column up to plinth level. ठीक है? अब इसमें मैं दो quantities calculate करूँगा. In this case, I am going to calculate two quantities. या फिर उसके पहले एक काम करते हैं. ठीक है? So write down RCC of column up to plinth level. RCC of column up to plinth level. ठीक है? Now consider plinth level 0.45. Consider plinth level as 0.45. So again, serial number, particular number, L, B, H, quantity. Clear? Now what I want? I want the quantity of column up to plinth. From where? From this point up to this point. Clear? So for F1, जस्ट कंसीडर फॉर F1. अब ये कैलकुलेट करते समय सबसे इंपॉर्टेंट पॉइंट है हाइट ऑफ कॉलम व्हिच इज नॉट सेट. अब ये हाइट नहीं मालूम है. From this point to this point, first we have to calculate this height. Now how we are going to calculate this height? See, this is known to you, which is 3 meter. Then up to this is 3.45. अब इसमें से आप क्या माइनस करोगे? थिकनेस ऑफ पीसीसी. क्या माइनस करोगे? कैपिटल की वैल्यू है F1 और F2 के लिए. क्लियर? इसका मतलब ये है कि C1 और C2 का लेंथ अप टू प्लेन अलग रहेगा. राइट? सो फर्स्ट कैलकुलेट द लेंथ. सो फॉर F1 or say for C1, first length is equals to what? 3 plus 0.45. 3 is depth of excavation, 0.45 is the pin height. This is 3 meter. यहाँ से यहाँ तक, and this is 0.45 minus what? Thickness of PCC minus C1 किस फुटिंग पे? F1. तो F1 का ये डेप्थ मुझे चाहिए, राइट? सो देयरफॉर माइनस कितना है? 2.85 meter. Calculate for C2. L is equal to 3 plus 0.45. This is okay. PCC thickness 0.1 minus capital T 0.35. So define this is thickness of PCC. This is capital T. Okay. Now do the simple calculation. Now C1, C2. C1 is 9, C2 is 2. What is the size? This is 0.23 by 0.4. 0.23 by 0.4. And this is 0.23 by 0.23. Now what is the height? C1 2.85. And this is, do the summation. समझ में आया? Next week I will give you that group assignment for 30 marks. ठीक है? एक और पॉइंट है, ऐसा नहीं रहता कि अगर C1 कॉलम है तो उसको F1 ही फुटिंग रहेगा. जब आप एक्चुअल प्रैक्टिस करते हो तो ये भी हो सकता है कि C1 कॉलम 3 टाइप के फुटिंग पे हो. मतलब किसी जगह पे C1 F1 पे हो, किसी जगह पे C1 F5 पे हो, तो अकॉर्डिंगली यू हैव टू कैलकुलेट. ठीक है? सो इट इज नॉट नेसेसरी कि C1 है तो F1 ही रहेगा. हो गया? कितना है? How much? 6 unit cubic meter. Unit is cubic meter. Now अब मुझे क्या चाहिए? नेक्स्ट क्वांटिटी इज, राइट, नेक्स्ट क्वांटिटी इज refilling of excavated material, refilling of excavated material. देखो दो फिलिंग आएंगी, एक आएगा excavated filling and second one is a plain filling. These two are different. So next quantity is refilling of excavated material. मतलब जो मिट्टी आपने एक्सकेवेट की उसको भी आपको पिट में डंप करना है, रिफिल करना है. क्लियर? अब उसकी क्वांटिटी मुझे चाहिए. अब ऑब्वियसली जितना आपने एक्सकेवेट किया उतना तो क्वांटिटी नहीं जाएगा. व्हाई? आपने पीसीसी किया, उसने कुछ वॉल्यूम लिया, आपने 14 कास्ट किया, उसके बाद में अप टू ग्राउंड लेवल आपका कॉलम भी. बट डू यू हैव दिस क्वांटिटी विथ यू? वॉल्यूम ऑफ कॉलम अप टू जीएल. आपके पास कौन सी क्वांटिटी है? वॉल्यूम ऑफ कॉलम और आरसीसी ऑफ कॉलम अप टू. Now calculate for refilling point of view volume of column up to ground. So write down title. Title is refilling of excavated material. Refilling of excavated material. क्या क्या आएगा इसमें? Refilling of excavated material is equals to total excavation. Total excavation. वो जो हमने सीरियल नंबर 1 सीरियल नंबर 2 किया, दोनों का टोटल. इसमें बाइफरकेट नहीं करते क्योंकि आप ऊपर से नीचे मटेरियल फेंकते हो, तो आप 1 मीटर पे फेंको या 2 मीटर पे फेंको, लेबर सेम लगता. सो डोंट डू द बाइफरकेशन की अप टू 0 टू 1.5 मीटर, 1.5 मीटर टू 3 मीटर. ये कंसेप्ट वहां पे नहीं लगता. टोटल. सो टोटल एक्सकेवेशन माइनस व्हाट? वॉल्यूम ऑफ पीसीसी और क्वांटिटी ऑफ पीसीसी माइनस क्वांटिटी और वॉल्यूम ऑफ फुटिंग माइनस वॉल्यूम ऑफ कॉलम अप टू जीएल ग्राउंड लेवल. अब इसमें से सारे नोन है अप टू जीएल नहीं है हमारे पास. क्लियर? तो कैलकुलेट करेंगे. अब वो कैलकुलेट करते समय क्या, ये 3 मीटर आपको 3 मीटर यहां से लेके यहां तक, उसमें से क्या निकालोगे? पीसीसी. उसमें से क्या निकालोगे? फुटिंग. सो 3 माइनस 0.1 माइनस 0.5. ठीक है ना? ये जीएल है, आपको ये हाइट पता है कितना है? 3 मीटर. उसमें से आप क्या माइनस करोगे? मुझे अभी ये हाइट चाहिए. I want this side. So 0.1 minus this. So 3 minus 0.1 minus 0.5 and इस केस में 3 minus 0.1 minus 0.5. कितना है? How much? 2.4. यहाँ 5. ठीक है? तो यहाँ पे वैल्यूज चेंज कर दो. This is 2.4 and this is 2.5. Clear? दिखा रहा है. ये चीज मैं इंटरपोलेशन से कैलकुलेट नहीं कर सकता था. व्हाई? हाइट कम ज्यादा है. इंटरपोलेशन में हम कहां कर सकते थे? तो लोड बेयरिंग स्ट्रक्चर में. वहां पे हमने किया भी था. यहां नहीं कर सकते, हाइट अलग है. कितना है? Two point 2.25. Okay. So what we will do? So refilling, quantity of refilling. So tell me expression quantity पहला सेकंड का करके मैं टोटल मतलब बाइफरकेट करता 49.2 plus 49.2 plus PCC कितना है PCC वॉल्यूम कितना है 3.28 minus minus RCC volume summation 6.02 minus ये 2.67 2.25 कर रहा है 2.67 मुझे ये चाहिए वाला ये सही है कि गलत 2 पॉइंट so कितना है ये टोटल एक्सकवेशन है राइट I want this column volume of column up to GL कितना है सॉरी 86.84 ठीक है now we are assuming what we are assuming कि इतना मटेरियल उस एक्सकेवेशन पीट में जाएगा एक्चुअली नहीं जा why क्योंकि जब आपने एक्सकेवेट किया था at that time that material is in compacted form but when you are dropping this material or refilling this material is not in compacted form इसलिए आपने जो भी 86 कैलकुलेट किया वो 86 मटेरियल क्यूबिक मीटर वहां पे नहीं जा इट इज लेसर देन दैट व्हाई बिकॉज़ देयर इज मोर वॉइड्स इन योर सॉइल तो कुछ लोग इसको ऐसे कैलकुलेट ना करते हुए जो भी आपका एक्सकेवेटेड मटेरियल आता है रिफिलिंग का मटेरियल आता है तो उसको दे आर सिंपली कंसीडर 60% मतलब अगर आपने टोटल 100 क्यूबिक मीटर का एक्सकेवेशन किया रिफिलिंग को कंसीडर करते 60% ऑफ एक्सकेवेटेड मटेरियल अब ये 40% मटेरियल कहां जाएगा that material is transported from your site to the some other place for the stacking purpose तो यहां पे लिखो भी what quantity of material transported from site to some other place for stacking उस मटेरियल का करोगे क्या so quantity of material transported from site of construction to where some other place for stacking क्लियर अब ये गवर्नमेंट प्रोजेक्ट में ये जो स्टैकिंग डिस्टेंस होता है इस स्टैकिंग डिस्टेंस को फ्री ऑफ कॉस्ट अप टू 5 किलोमीटर कंसीडर करते हैं मतलब अगर आपने कहा एक बंदे को कि यहाँ पे मुझे बिल्डिंग बनाना है गवर्नमेंट यहाँ पे जो भी मटेरियल निकलेगा उसको आपको स्टैक करना है अप टू 5 किलोमीटर डिस्टेंस देन इट इज फ्री ऑफ कॉस्ट देन देयर इज नो एनी काइंड ऑफ लीड चार्जेस बट इफ सपोज दैट डिस्टेंस इज मोर देन 5 then for that extra distance client has to pay clear so free lead कितना रहता है 5 किलोमीटर in case of government project दो वर्ड हमेशा आते हैं लीड एंड लिफ्ट लीड means when you are moving horizontally lift means when you are moving vertically Clear? So okay, we stop. Tomorrow we will again reconsider the same problem. Only thing is, I just give the sizes. इसका पहले स्केच क्राफ्ट करो AutoCAD में. Clear? For the proper distance purpose. कॉलम का ओरिएंटेशन जैसे भी है वैसे ओरिएंटेशन में ड्राफ्ट करना. ठीक है? अगेन एक्सटर्नल वॉल, पेरिफेरल वॉल 230 mm thick, internal wall 115 mm thick. 230 and 115 mm thick. ठीक है? और इसमें हम लोग कल फिर कैलकुलेट करेंगे कॉलम स्लैब वॉल. ठीक है? तो AutoCAD डिस्टेंस चाहिए सो दैट वी कैन कंपेयर दैट डिस्टेंस. ठीक है? एनी डाउट?
Hi, Falke.